So you can use ternary expressions in your widget tree, for example, to dynamically derive a value based on some condition or based on some other value in the end, therefore, in this case based on the value stored in ActiveScreen. But adding such ternary expressions here in the widget tree can also make the code a bit harder to read. It also might be easy to overlook this. And therefore you might prefer an alternative approach, which I also want to show you. Instead of using this ternary expression down there, you could also go to your build method, which is executed when the widget is rendered for the first time and after setState is called. And in there you could introduce a new variable, which is now only available inside of the build method. So this is now not a class variable, it's not like ActiveScreen, which is available in the entire class, but instead it's a variable scoped to this build method and only available in this build method. And this variable could have a name of screenWidget, though the name as always is up to you. And it could initially be set to startScreen, which still receives the switchScreen function as a value. But now I want to make sure that screenWidget is set to a different value if ActiveScreen is not startScreen but questionsScreen. To achieve this, we could cut this ternary expression and use that up there. And then we could actually even set this to final, because now this never changes. It's only set once whenever the build method runs, either to startScreen or to questionsScreen. And you could then use screenWidget as a value down there for child, so that the value stored in screenWidget is passed as a value to the child argument, and that screenWidget value is derived dynamically with a ternary expression up here. You could do that, but with that you would of course still be using a ternary expression, though now at least outside of the widget tree, which already could be considered to be a bit more readable. But I want to show you a different approach. Hence I'll go back to storing startScreen as an initial value in screenWidget, and I'll set this back to be a variable, because now I conditionally want to set screenWidget to questionsScreen if a certain condition is met. Now for that, first of all, the type here for screenWidget should explicitly be set to widget, so that it's not inferred in a too restrictive way. We did that a couple of lectures ago already, if you recall. But now this code here should be executed conditionally. And for that you can use another keyword provided by Dart, the if keyword. That's a crucial keyword which you need to use a lot, which is why I'm introducing it here, because if allows you to specify a condition between parentheses, and then you add opening and closing curly braces, and the code between these curly braces will then only be executed if this condition is met. So now we could cut this code here and paste this here into this if statement body. And the condition that should be specified here is now almost the same as before in the ternary expression. We want to compare ActiveScreen, so this variable, which is dynamically updated if the button was pressed. We want to check if it's equal to questionsScreen now actually, because we then set screenWidget to questionsScreen if the identifier is equal to questionsScreen. And here we can add const. And with that, whenever the build method executes, the screenWidget variable is initially set to startScreen, but it then might be overwritten if this condition is met here. So if ActiveScreen is questionsScreen, then screenWidget would be overwritten. And that's an alternative pattern of setting content conditionally, because now screenWidget can of course be used down there as a value for child, and therefore it will now either be startScreen or questionsScreen that is set as a value for child. And that's the last alternative I wanted to show you. If we save this and force a reload, the app still works as before, but now using this approach. And as mentioned before, I simply showed all these different approaches because we'll need them from time to time throughout the course. And as a Flutter and Dart developer, you of course must know about these different approaches so that you can solve the different problems you might be facing when working on your own project, or also when working together with other colleagues that might be using one of these approaches.